All right, so today we're really going to dig into the story of Stephen Hawking.
Oh, yeah.
But before we get too far into it, I just want to let the listeners know that even if you don't know much about physics,
Right.
this is still going to be a really interesting deep dive.
Yeah, you don't have to be a rocket scientist to appreciate Stephen Hawking's story, that's for sure.
Exactly. We're really interested in the human element of his story here.
Definitely.
And luckily for us, you found us an incredible biography that really gets into what made him tick.
It's a great book, yeah, and it really shows you how he became the Stephen Hawking.
Right, exactly. Like even before he was, the Stephen Hawking.
Yeah, exactly.
So why don't we start with that? Like, what was he like as a kid?
Well, you might be surprised to learn that Hawking wasn't always, top of his class or anything.
Really?
Yeah, he was a smart kid, definitely curious, but his grades were actually pretty average, at least at first. It wasn't until he went to Oxford that he really found his passion for physics and cosmology in particular.
Cosmology. So like the big picture stuff, the whole universe.
Exactly. The origin, the evolution, the whole shebang.
So he finds his passion, he's at Oxford, he's on his way, and then boom, at 21, he's diagnosed with ALS.
Yeah, can you imagine?
It's like just as he's getting started.
And ALS, for anyone who might not know, it's a really tough disease. It affects the nerve cells that control your muscles. It makes walking, talking, even breathing incredibly difficult.
I mean, I've heard of it, but yeah, I don't really know much about it.
Yeah, and back then, the prognosis was really bleak. They gave him just a few years.
Wow, so at that point you almost think, okay, well, that's it then. Like, what do you even do with that?
You would think so, right?
Yeah.
But not Hawking. He just refused to give up.
He seemed like he was driven by, I don't know, like he just wanted to prove everyone wrong or something.
I think it was more than that. I think the diagnosis really lit a fire under him. Like he wanted to make every second count.
That's incredible. And it was right around this time that he met Jane Wilde, his future wife.
Right. Talk about a love story.
That's amazing. So he's dealing with this diagnosis, he's falling in love, and on top of that, he's tackling some of the most challenging ideas in physics.
Well, he was never one to back down from a challenge, that's for sure.
So let's talk about some of those challenges. What were some of the big questions that he was wrestling with?
Well, one of the biggest was black holes. Before Hawking, people thought of black holes as these kind of cosmic vacuum cleaners, just sucking up everything around them, no exceptions.
Right, like nothing can escape a black hole.
Exactly. But Hawking, he came along and said, hold on a minute, what if it's not that simple?
And that's where Hawking radiation comes in, right? I've heard that term, but I'm a little fuzzy on what it actually means.
Yeah, so Hawking radiation was a revolutionary idea. He said that black holes aren't completely black after all. They actually emit a very faint type of radiation. And this radiation, it's caused by some really weird quantum mechanics happening near the edge of the black hole.
Quantum mechanics. Okay, we might need to break that down a little.
Right, so in a nutshell, quantum mechanics, it's the study of how things work at the tiniest level, like atoms and subatomic particles. And it's a weird, wacky world down there. Like things can pop in and out of existence.
Okay, so we're already in kind of a mind-bending area.
Right, so Hawking realized that these quantum effects, they actually have a big impact on black holes. Imagine tiny particles popping into existence near the event horizon, the point of no return for a black hole. Sometimes one particle gets sucked in while the other escapes. And that escaping particle, it carries a little bit of the black hole's energy with it.
So the black hole is actually losing energy.
In a way, yes. It's like it's slowly evaporating over billions and billions of years.
Wow, so it's not just a one-way street. Things can come out eventually.
Exactly, and that was a huge deal because it challenged everything we thought we knew about black holes.
And not just black holes, right? It's like it brought together these two massive ideas in physics: general relativity, which is Einstein's big theory of gravity, and then quantum mechanics, which governs the really, really small stuff. Before Hawking, those two theories, they didn't really get along.
It was like trying to fit a square peg in a round hole,
Huh?
you know? But Hawking, he found a way to connect them.
Which is incredible. He found a way to connect those ideas. He completely changed our understanding of black holes, and he did it all while facing this incredible personal challenge.
Yeah, it's really quite remarkable when you think about it.
So he's dealing with all of this, and he still manages to become one of the most famous physicists of all time.
Well, it wasn't just the science, it was the way he communicated those ideas.
You're talking about his book, A Brief History of Time.
Yeah, exactly.
Yeah.
That book, it came out in 1988,
Okay.
and it just blew up, became a bestseller, translated into a zillion languages.
I remember seeing it everywhere. Though, to be honest, I never actually read it.
Yeah, it wasn't exactly a walk in the park. content-wise.
Like trying to read a foreign language, probably.
Kind of, yeah. But even if you didn't understand all the physics, there was just something about it that captured people's imaginations.
Yeah, I mean, he was talking about the big questions, right? Like, where did the universe come from? What is time? Stuff like that.
Exactly. The kind of questions people have been asking since, well, forever.
And here's Hawking with his wheelchair, his synthesized voice, explaining these mind-blowing concepts.
He wasn't just a scientist. He was like a symbol of, I don't know, the power of the human spirit or something.
Totally. And he wasn't afraid to get into it with other physicists either, was he?
Oh, not at all. He loved a good debate.
He was known for challenging other scientists, even those he admired.
Yeah, he was always pushing for deeper understanding, even if it meant being wrong sometimes.
Which is a good lesson for all of us, right?
Absolutely.
Speaking of challenging questions, we have to talk about the black hole information paradox. That one always makes my head spin.
Yeah, it's a real head scratcher. So imagine you throw something into a black hole, like a book.
Okay.
Common sense says it's gone forever.
Right, swallowed up.
But then quantum mechanics comes along and says, not so fast. See, quantum mechanics has this rule that information can never be truly destroyed.
Wait, so what does that even mean? Information can't be destroyed?
It's weird, right? But think of it like this. Everything in the universe, at its most basic level, it's all just information. The arrangement of atoms, the spin of particles, it's all information. And quantum mechanics says that this information, it can't just vanish.
Okay, kind of see what you mean.
So the paradox is this. If information can't be destroyed, but black holes seem to make things disappear, where does that information go?
It has to go somewhere, right?
Exactly. Does it get trapped inside the black hole? Does it somehow escape? These are the questions that keep physicists up at night.
And what did Hawking think? Did he have an answer?
Well, initially, he thought that the information was lost forever.
Really?
Yeah, which is a big deal because it contradicted some pretty fundamental laws of physics. But then later on, he actually changed his mind.
He admitted he was wrong.
He did. He came up with a new idea that maybe the information isn't destroyed, but it's somehow encoded in the radiation that's emitted by the black hole.
So you're saying there's a chance that what goes into a black hole doesn't actually disappear completely?
It's possible. Though how that information would escape is still a mystery. It's one of the biggest unsolved problems in physics.
It's incredible that even someone like Stephen Hawking, one of the most brilliant minds ever, could change his mind about something so fundamental.
It just shows you that science is a process. You know, it's not about being right or wrong. It's about constantly questioning and refining our understanding of the universe.
So he was willing to admit he didn't have all the answers.
Exactly.
Which is like kind of reassuring in a way, right? Even Stephen Hawking got things wrong sometimes.
It's like you were saying earlier, science is a process. It's not about being right all the time. It's about being open to new ideas, new evidence.
And that's what's so inspiring about Hawking. Even with everything he was going through, he never stopped questioning, never stopped exploring.
It's like his physical limitations. They always seem to, like, fuel his curiosity, you know?
It's like he was determined to prove that our minds, our imaginations, they're not limited by our physical bodies.
Exactly. And he did it all with such a great sense of humor, too.
Yeah, he never took himself too seriously, did he?
Not at all. He was always cracking jokes, making appearances on TV shows, even guest starring on The Simpsons.
Which is amazing. It just shows you how much of an impact he had, not just on science, but on pop culture as well.
He became a global icon, a symbol of the power of the human spirit.
And it all goes back to that idea of never giving up, no matter the odds. He really lived that message, didn't he?
Absolutely. He never let his condition define him. He kept pushing boundaries, breaking down barriers, both in science and in life.
And he left behind an incredible legacy. He inspired generations of scientists and really anyone who ever heard his story.
His message was simple but powerful. Never stop questioning, never stop exploring, and never, ever give up on your dreams.
And on that note, I think we should wrap up this incredible deep dive into the life and work of Stephen Hawking. It's been a truly inspiring journey.
It really has.
If you're interested in learning more about Stephen Hawking and his incredible journey, we highly recommend checking out the biography we discussed today, as well as his book, A Brief History of Time, which, fair warning, is a bit of a challenging read, but well worth the effort.
Definitely worth it.
Thanks for joining us on this incredible journey, and until next time, keep exploring the universe and all its mysteries.
See you next time.